All right, we're back. We're going to make a 3D error surface of an affine function with a ReLU. So it's about to get wild. Okay, so, all right, let's make a ReLU function of x is equal to if x is less than 0, then 0 else x. Okay, so we've got ourselves a ReLU. And then, what else do we want to do? We're trying to make an affine plus ReLU in 3D. Let's go ahead and make ourselves 2 points. Let's do here and here. Who knows? Okay. All right, and so now what we want to do is we want to graph the error surface. Okay. So how do we do that? Let's put something inside a ReLU. Okay. And so that's going to be x times the x of a, the component of a, plus y, because x is our w value and our y is our b value, our bias, okay, minus the y of a all squared. Beautiful. Okay, I think that's right. So that's kind of cool. I mean, let's just pause and take a look. So that's what that error surface looks like for just A. Pretty interesting. Okay. So I'll go ahead and grab the rest of this for B, and I'll grab the rest of it and we'll copy and paste it for B. Okay. So we'll go ahead and remove the A. We'll remove the A. Alright, so now there's our error surface for B. Pretty cool. Am I missing anything? I don't think so. So let me just go ahead and let's add these together. X, y plus A, X, y. Is this what we want? Alright, let's see if we can get a good image of it. Yes, I think this looks right. Okay, so first of all, there's a couple things to note. There's this big flat region. Look at all that. It's pretty cool. And then all of this stuff is not flat, and in particular, there's a minimum. Man, this minimum is a little hard to see, isn't it? Let's come on over here. Let's go down here. Okay, that looks better. The minimum appears to be right here. Let's see if I can kind of zoom in here. Try to get us that minimum value. Let's go ahead and see if we can draw a point on there. And it's somewhere. It's kind of hard to draw. Oh, goodness gracious. Is that it? I don't think so. Let's rotate a little bit. Maybe I can see it better under here. Honestly, I think I may have gotten it somewhere right around there. Okay, so what is that point? Oh, it's just 0, 0, 0. So let's make our weight and our bias. So let's make our function now. ReLU of w times. Whoops, we need to make a w. Let's make a w and a b. Okay, b is already named as a function, so I'm going to remove this. I'm going to rename this function d. Okay, now let's make ourselves a b. Down here, b. Okay, that works. Okay, ReLU of wx plus b. Okay. And let's get rid of that ReLU. And what did we say? We said we're about 0, 0 right here. 0, 0. Okay, 0, comma 0. Let's see. So it's a little off, right? It's not perfect. Right? So this is the ReLU we're getting, but we want it to have some slope. And it looks like maybe up here is where our minimum is. Our minimum is probably not at weight equal to 0. Let's see here. Let's see here. Yeah, so this weight, it's kind of hard to see. It looks like it's about 0.25 maybe. Let's try 0.25 for our weight. Alright, so we changed it to 0.25. Okay, that's a lot closer, right? In any case, you can see that we've got some kind of cool behavior here. Let's think here. What's a way we can make it a little bit more interesting or more easy to see? Well, first of all, this is super curvy and it's kind of annoying. So I'm gonna make it a little less curvy by bringing A over and by bringing B over, because if their x values aren't as big, these are going to be less curvy, right? So let's bring those x values in. All right, so now it's less curvy, and now, oh my goodness, it's much easier to see. Okay, it's still kind of hard to just see straight vertically. Maybe about right here. Maybe we move C over there. Yeah, probably about like that. What is that? It's about 0.5, something like that. So let's give this about 0.5, and this is about 0.5, and that's looking pretty good now. Okay, so there's a couple things to notice. So first of all, there's this flat region, and if we were initializing our weights and biases, right? If we were initializing some point, so let's go ahead and let's give ourselves a W comma B. And I think that's this point. Actually, you know what I'll do? Let's go ahead and do this. So I'm going to delete this. Okay. I'm going to draw us a point. I'm going to do it like we usually do it. Okay, we'll draw a point here. And then we'll say, okay, W is going to be the x value of D. Okay. And the bias is going to be the y value of D, or what point was it? D? Yeah, y value of D. Okay. So now we're going to move this around. This is cool. Yeah, we're going to try to get it just right. And so that should be about the minimum point. And sure enough, look at that. It looks just about like the minimum. So very good. Okay. There's a couple other things to notice. So first of all, this also has that behavior of, we've got, let's turn this off and then just do one at a time, right? You can see that this one is just like diagonal this way, and just like we had without the ReLU, right? So if we didn't have the ReLU, right? Remember, we just had a parabola looking like this, but the ReLU flattens out this part. And, the other one has a similar behavior, right? It's just it's just angled a little different. In any case, these are adding together to make this final curve, right? So we've got this slanted part here, we've got the slanted part here, then we have the part where those parabolas meet, and then, we have this flat region as well. There's one other thing I want to point out, is that if we move D, so D is our weight and bias that we're, trying to optimize, right? So if we initialize D down here, just by happenstance, D is in a flat region right now. So D is a completely dead ReLU, right? We can't, we're not changing anything, right? So if we go in any of these directions, the gradient is 0. And that makes sense because as I change D, you can see this ReLU underneath it. That's not changing any of these, the accuracy of these predictions, right? And that's why the slope is 0. That's why the gradient is 0. But now once I come out of this flat region, okay, now all of a sudden things, changes I do make a difference, right? So this is pretty cool. You can drag this around and see how your ReLU changes, It's kind of doing a little dance underneath there. But yeah, I think that's all I wanted to point out. Thanks for watching. Hope it was interesting.